Hello, my name is Anna Mueller. I am a senior architectural engineering student at the University of Cincinnati, and this is my E6 research project. It's over generative design in Revit, the future of AEC. And this is for a class called ARCH7014 taught by Professor Ming. So let's get right into it. So generative design in Revit um, is basically a new feature that has been added to Revit that allows for generative design in the program. But what is generative design? Generative design is the data-driven, algorithm-based process of solving complex design problems by inputting variables, parameters, and factors, and generating iterations of the most optimized designs to fit those needs. There are a lot of uses for generative design, especially in the AEC industry, and some of them can be optimizing parking lots. So perhaps you have a site for a parking lot and you want to know all the different configurations that you could put parking spaces to allow for maybe the most parking spaces on the lot. There's also stadium seating, maybe how far to put the bleachers um, so that everyone can see, but like also adding as many seats as possible. There's also COVID-19 seating in restaurants. Ever since the pandemic back in 2020 and kind of surrounding months, years, I guess still kind of existing, um, a lot of restaurants have needed to redo their interior placement of their furniture so that it's all 6 feet apart, part of the social distancing policy. And generative design has helped them come up with different ways to put their furniture so that it reaches those social distancing requirements, but still has a lot of seating available for people. Medical facilities for maybe the placement of all the different rooms that are needed, or maybe for determining paths for nurses, doctors to get to from point A to point B in the shortest amount of time. Window lighting, so this could be like maximizing the views or the light inside depending on where you put the windows or where you put objects or obstacles on the inside that are obstructing that light. And then also manufacturing is the last example I'll talk about, and it's basically if a company is creating a product, for example, a reception desk, and they have a certain wood pattern on it with cutouts in it to create something aesthetic, something nice. Using generative design may help in them coming up with a pattern that is easy to produce and causes less waste, but also has like an interesting pattern for us to see. So a brief history of generative design, kind of like, how the computer was invented. There's no like really start date or single person that came up with its invention, but it started around the 1970s. One of the first generative design projects ever implemented was the Palladian villas made in 1978. This was made creating, or this was created with a shape grammar. The shape grammar kind of created the floor plans for this structure, and we can see this structure actually in my picture to the lower right. In the 1990s, architects and engineers then began to really see the potential and take generative design seriously, and they began looking into the technology and improving that so that it becomes even better, so that they can use for projects. So in present day, the capabilities of technology have come so far, and now AI can produce many, many different iterations. But not only can it do that for us, but it can also analyze them and help the user in choosing the designs that best fit their needs and have the highest performance. So the benefits of generative design include the fact that computers can produce, hundreds and hundreds of permutations, design concepts, drawings for a certain need, and it may take a person or a team of people, like several days just to create a few. And just from that factor alone, it is easy to see how generative design has the potential to be a very, very useful tool for the AEC industry. Um, Something else that's really important is that not only will it produce these and help people choose the right ones, but the process can really be broken down even more efficiently by having people, see what is available, see all the options, and then choose, oh wait, something else happened and they need to redefine it. They can quickly use their tests or their studies that were already created and just modify the factors that they first put in, and then it can easily, quickly produce more permutations based on what they said and or what they edited, and it creates a very streamlined way um, as things are constantly being updated and goals constantly being redefined. So there are sort of small downsides to generative design. Um, Generative design really, since it is so efficient, it can kind of cut out positions that would normally be producing all these designs by hand, because it can produce so much for people in minutes that could take, a lot of people days. It could result in job risk and job loss in the future. Um, Another important thing to note is that with generative design, there are very high expectations for it, and so people think that once they get all these designs from the AI and they see that it's optimized for all the needs and goals that they set, they may not think of any other options, and that can hinder us possibly in the future. Um, it might not allow us to be as creative as we otherwise could be, and also it might not account for all of the design problems that will actually arise if we're only putting in the constraints that we know in the program. So generative design workflow, essentially, based on what Revit's website talked about, there are six steps. There's generate, analyze, rank, evolve, explore, integrate. From these steps, we can kind of see how the design process is supposed to work, even across other generative design platforms, features, and stuff other than Revit. But with the first one, generate, that's basically when um, say you already have all your constraint goals, variables, everything that you already need. You plugged it in and you clicked on generate. Now the computer is generating all of these different options for you to select from. The second is analyzing. That would be you and or the computer going through and analyzing all your different options to see which is the best for your project. The third is ranking them. This is kind of like analyzing. You're going through and you're choosing the best ones, um, putting the best ones in a notable area. The other ones you're tossing. The fourth one is evolving. This is where you're redefining your problems, your variables, constraints, goals, and you are replugging them into the algorithms so that they create new options as you're refining it further. Exploring is kind of where you're really looking through all the different options that you have and choosing the one that's best for you, even the ones because there might be multiple that are so far from each other, they both might work for your needs. And then the last one is integrating. This is actually implementing the design into a tangible form, like actually making it into construction docs after you've detailed all of the architectural docs you need, but then like building it and so on. This is the design workflow in Revit. This is essentially a very brief, short little snippet of how you actually do generative design in Revit. Essentially, you redefine your goals, and then you put it into the study. So you put in your static inputs, your variable inputs, and then once you do that, and you hit generate, what it kind of does behind the scenes is it goes through functions, which we can see functions are the series of scripts that run the inputs through the designated design code. And then it goes to visualization. This is when the computer has all of its design options already decided upon for optimizing what you had input. It just needs to create the graphics for them. So the geometry that is generated from running the scripts is made. And then evaluators comes next, and this is where the data and information given about the designs generated in relation to the preset goals, all the data that is involved with what it's made is really came up and analyzed. And then generative design, it's like the final outputs, it's what you see, it's all the repetitious iterations that come up, and it really creates an algorithm specific to your study so that each time you do it, it can further and further refine it. And this is kind of like a loop where you can keep going until you're satisfied with the results. So there are several firms that already utilize generative design in their building projects. Just a few of them real quick would be Zaha Hadid Architects. They created the Haydar Aliyev Center. This is in Azerbaijan. Sorry if I pronounced that very wrong. But as we can see in the first picture, it is very probably hard to think or produce something like that just by thinking about it, I would think, but it was generatively designed and it's created a very unique shape. This building actually holds like a library, a museum, a music venue, and other sort of things for people. The second one is Autodesk. So Autodesk has offices all over the world, but this one's in Toronto. And this kind of shows people, what they can do with the generative design process by making their own. And it's the Technology Center. Essentially, this is the first office building to utilize generative design to the scale that they did. It's about 60,000 square feet over 3 stories, So it's pretty large, and they really had a lot of people help work on it with them. So they had 250 employees, give or take, put in their preferences for their office environments. And then they had like 10,000 different iterations that came up that they went through and analyzed before finally selecting and refining the one that they chose. The next one is the Daiwa House Group, and this is a place in a company in Japan, and they create a bunch of urban houses in Japan. Um, this picture is just one of the houses they make, but essentially they really go through and use generative design to help choose all the different materials and like residential layouts that um, would help them in that sort of private sector. And then this is Stamhuis, or I'm not sure on the pronunciation, but they are located in the Netherlands, and they are basically a company that makes lots and lots of stores, like huge supermarket chains or small stores, and they really utilize generative design as well for their interiors and laying out, all the merchandise, the aisles, just the layout of stores. And then the last one is by a German architect, by a name that I can't really pronounce, but he belongs with a group called ARUP, located in the UK. But he designed this with generative design, and it's the Metropole Parasols, and it's actually one of the largest timber structures ever made. Okay, so getting into generative design in Revit, generative design in Revit has basically been a new feature, but it's always kind of been in Revit as another open source feature called Dynamo. And I think Revit or Autodesk is making like their own, perhaps like more intuitive feature for generative design directly in their software, so you don't have to worry so much about Dynamo. And Dynamo is essentially just a visual programming language, kind of like how Grasshopper is to Rhino 3D. But essentially, the different goals that you could set in your generative design in Revit are based off of three different things, which I will soon show you. It's office workspace layout, maximizing window views, and 3D three-box massing. But the example here to the right is just goals for the office space one. Like you want low distraction, adjacency, preference, interconnectivity, daylight, views to outside, and work style. And you can really set what you want in Revit using their new generative design feature. So here we can see the different ones that Revit has so far, and I believe they will be adding more. But essentially maximizing window views, it generates various viewpoints for a specific spot that you select in a room, and it'll show all the different lighting coming through the windows, as well as your views out and angles outside of them, and any obstacles that may be in your way to the view of the windows. Three-box massing, it generates just very simple volumes, up to three. It can be like 1 to 3 boxes that will appear that you can choose. And like you can choose kind of like how much surface area or floor area that you want each of them to be, so that you can really start to form a dynamic building form, whether you're like an architect looking to build different multiple different buildings, say, on the same site, or you're an urban designer trying to figure out your city's physical urban form. Then workspace layout, essentially desks, chairs, or whatever furniture systems you have in a room. You can decide how you want to lay it out by setting all your variables and constraints using this generative design feature. So we will jump into a tutorial on how to use generative design in Revit by starting with the first one, workspace layout. In workspace layout, actually, when you first open Revit and you start a new project, you want to go to the Manage tab, and then in like one of the feature panels, you're going to choose Generative Design and then Create Study. And then the Create Study window will pop up, in which you'll first choose Workspace Layout. After you choose that, a new window will appear, which will be the one to the far right. And you add a study name. You can choose a method, and I go over that more in my video tutorial, but essentially everyone chooses optimize. Then you select these two links so that you can choose from your model the respective links it needs, and then you can choose your variables, your goals, and your constraints, and then you can click on generate and it will generate. It takes a long time for it to generate, probably 5 to 10 minutes. Some outcomes might start appearing before then, but not all of them will be completely finished for a while. And actually, like, there's about 10 steps that Revit takes to do this, so you can kind of see the loading progress of it. But from my workspace layout, this was the room that I had to test with, and I just created a simple room. You could like possibly a classroom, because it's like a classroom. There'll be like windows only on one side usually, and then maybe 2 doors, and you only need to put in one Revit element or family. This is just a desk, and it has to be a room as well. But then the outcomes that I got from it are all listed in this picture. There's actually 2 pages, so there's more. But we can see like what the computer decided was best for the layout of all these different desks based on, the number of desks, their spacing, their paths of egress to the exits, and from the windows, what the viewing angles are. This little graph below, if you hover over them, and I go over this more in my video tutorial as well, that comes later, a darker line will appear, and that shows you exactly what outcome it's pulling the variables from. So like it would show like which number or desk rotation degree it'll be at, and like the number of feet between the rows for that particular one, and so on. So it's pretty useful to see for if you have something that you prioritize over the other from these 5 things. You can really sort them the way you want. It's also nice because what you can do is you can click and drag a region so that only the outcomes within the region, and you can do that with each of these 5 columns, so that only the outcomes that appear within those regions will show here. And you can also click on the region and slide it around so that it kind of makes it easier when you're just doing some quick little adjustments. The next one is maximize window options. So kind of the same thing as workspace layout. You go to manage, Generative Design creates study, and then this time you click on maximize window views. So there are different variables, goals, and constraints for this one because this is a new study. And so you're not going to see the same thing for each of the studies. But this was the room that I created for the Maximize Windows design study. And I created a little bit more of a unique shape so that we can really see what the program does. There are a lot of windows I added. These are just architectural columns so that I could have obstructions. And this is just a chair. Click Generate, and these are the outcomes that come up with. So it was a little weird that these showed nothing, but there are 2 pages, and the other 2 are filled with ones that look like this, that have the yellow viewing angles clearly shown. And we can see from these where the chair is in the room, what views it has out all the windows, and it's very interesting. We also see the outside score is 50, which is pretty high, at least in this study that I've done, because these are very low. This is like 61, 62, so you can really see all the different outcomes for that, where the chair would be. This is then the very last one, 3-box massing. You do not need a model. You do not need to like link elements from a model into the study. You simply click on the 3-box massing option and click generate, and it'll come up with a new window. It'll come up with a new window that will actually show kind of like before new things, but for the boxes instead. And you can actually choose the number of boxes you want. You could have 1 to 3 boxes. I know I stated earlier you could choose a floor and surface areas of them, and heights. There's other constraints that you can set as well. But then you just come up with your outcomes. They appear. You don't need to do anything. You can do the study just directly within the program. And the same as before, you can mess around with the different sliders so that you can get the kind of results you want. It's very interesting. We can see all their positionings for each of them and whatnot. So that's basically it for the tutorial, just going over them verbally. But I, at the end, will attach a video tutorial that will have a very comprehensive review of all that I just talked about. Although I do, disclaimer, want to apologize. My computer was not working right, so I was using a friend's computer at the time in a public space, so you might hear a lot of people talking around me in the background, but my voice is still very clear, so you should be able to get what you need from that. So, any questions? But this is a video, so these are all my references, quite a few, and then thank you very much.